Sorry to drag you back into another session today.
Oh, no, don't worry about it.
I looked at this third page you sent me that we didn't get a chance to cover today.
Sure.
And I saw a couple of simple mistakes you made, so I figured since you got a quiz tomorrow, it would be worth letting you know about them. Okay,
Sure.
Let's take this first arithmetic series, 11, 10, 9, 8, ... Okay. This is the general formula for the nth term. Okay.
Okay.
So, let's write it out. What's my first term?
11. So 11 plus n minus 1.
What's the common difference?
It goes down 1.
So minus 1. Now, at this point, you have two choices. You can simplify that by multiplying it out and simplifying this whole equation. And that's kind of what they did in their example up here. They simplified it rather than leaving it like this.
Yeah.
But if they're going to ask you what the 30th term, is that a 20 or a 30?
That's a 20. Or, no, that's 30. Yeah, it's
Supposed to be a 30. In other words, their instructions say find a sub 30.
Oh, yeah. Yep, whoops.
That's all right.
20.
That's not the mistake you made.
Yeah.
Okay, so a of 30, that n is the same as that n. So whenever they say a sub some number, then I'm just going to plug it directly into this thing. So that's equal to 11 plus, and here you made a mistake of writing 30. What should it be?
Plus 30.
No, it's 30 minus 1.
30, okay.
So
yeah.
it's 29. It's always n minus 1.
Okay.
Okay? And then the second mistake you made is one that I've seen a few students make before, and it's very easy to make. And that is, you wrote the common difference down, but then when you went to solve the problem, you subtracted 1.
Oh, you're supposed to add 1.
You're supposed to multiply these two.
Or multiple. Okay.
That's what that means. That doesn't mean 29 minus 1. That means 29 times a minus 1.
Okay.
So my answer is 11 minus 29, and that is minus 18.
Okay.
Okay? Now,
Okay.
let's use a little common sense in some of these. If they want the 30th term, should it be positive or negative?
It should be positive.
We're counting.
Well, no, it'd be negative.
It's got to be negative. In other words, we're going to get to 0 by the 11th term.
Yeah.
Okay, so all of the terms after 11 are going to be negative. Minus 1, minus 2, and so forth and so on. So it's a good idea to have a general idea what the 30th term is going to be, what the sign's going to be. So when you did this problem and came up with the answer 329, you should have been suspect right then.
Yeah.
Because that's a positive number. You're not going to get 329 when you count backwards from 11.
Yeah. It's common sense right there.
Let's look at some of these errors you made here. You stuck 30 in place of n minus 1. So you just need to put 30 in place of n. And then 30 minus 1 would be 29.
Okay.
And then you had the minus 1, you just misinterpreted it. In other words, you then took 11 times 30 and subtracted 1 to get this answer. But notice it's 11 plus. In other words, you're not multiplying 11 times the minus 29. You're multiplying the d times n minus 1. So it's 11 plus a negative 29.
Okay.
Okay? So let's do the second one and see if you can do it without my help here.
Okay.
We don't have to go 30 minutes today. We cover this material in 15.
Okay.
I'll let you go. I didn't want to let you go to this quiz without better. What's the common difference? What's the first term?
Okay, so the first term would be 8 sub 6.
What's the common
And then
difference?
Plus 12.
Common difference is the difference between any two terms.
Yeah.
That's why it's called
Plus
the
6.
common difference. So it's
Okay.
plus 6.
Plus
What's
6.
the general formula? A
So
equals what?
A of n is equal to 6 plus n minus 1 plus 6.
Times a 6. Like that.
Okay. Yeah.
Okay? So now,
Okay.
what is A sub 30?
So A of 30, so the next formula would be A of n is equal to 6
Okay, I've got that already.
plus 30
Now
minus
I'm
1.
saying evaluate this when n is equal to 30. So 6 plus what goes here?
30 minus 1.
N minus 1, 29.
Yeah.
It's always going to be one less than this, okay?
Okay.
Times 6. Whatever
Okay.
that number results in, it looks like 174 plus 6, 180 maybe.
Okay.
And does that have the right sign on it? We've got a sequence here that starts at 6 and goes up.
Yeah. So yeah, it would be.
A big positive number is what we're looking for. If we were to get a negative number, we've made a mistake.
Mhm.
Okay?
Okay.
All right. Have a look at 14. Hold on just a second. I expanded it without meaning to.
No problem.
Okay, what's the first term?
So negative 9.
It's the common difference.
29.
Common difference is always the difference.
I mean, yeah.
How much do you have to, what do you have to do to get from minus 9 to minus 6?
Add 3.
That's the common difference.
Okay.
So now what is the general formula for this series?
So A of n is equal to negative 9 plus 29
No.
times 3.
Plus n minus 1
Or plus n minus 1
3.
times. Okay.
It's always n minus 1 times the common difference.
Yeah.
Okay? So now what is A sub 30?
Okay, so now A sub 30 would be negative 9 plus 29 times 3.
3 times 29 is 87. 78 is the answer. That is the 30th term of this sequence. And notice this sequence starts negative, but then it gradually works its way to 0, and then it's going to become positive. So we are looking for a big positive number, but it's 78.
Cool. Okay.
All right, and the only other part of this that we didn't really cover was, we kind of covered these, but, no, let's,
Yeah, these are a little different.
they're a little different only in one sense. All of the piecewise functions we covered, almost all of them, not all of them, but almost all of them, were horizontal lines. In other words, they looked like this. They were step functions. Either it was closed and open or open and closed, okay? So these are all equations like y equal 2, y equal 3, y equal 4. This is different in the sense that now we have y equal x plus 6, which is a linear function with slope, or y equal minus 3x, which is a linear function with negative slope. So we're going to end up with a piecewise curve that looks something like that and then that. Okay, so instead of horizontal lines, we're going to have straight lines still, but they're going to have slope to them. So let's do 16. Remember, always start from the right in thinking about these.
Okay.
Whenever x is less than or equal to 0, what does the function look like?
It's going to go, it's negative.
Well, hold on. It's this one right here. It's not negative. It's just that when x is less than 0, we're going to have that function. Well, what does that function look like? Where does that function cross the y-axis?
At 6.
Okay, so let's label that. And it would normally look like this. That's a slope of 1. It has a slope of 1. But since it's only true to the left of the x-axis, I only want to draw that part of it.
Okay.
With a closed dot right there because it's less than or equal to 0.
Okay.
Okay? When x is greater than 0, in other words, to the right of the y-axis, what's the function?
So if it's to the right, it would be...
In other words, this function here is y equal x plus 6. When we're to the right of the y-axis, in other words, when x is positive, what's the function?
X is greater than or equal to 0.
Y equals minus 3x.
Nice, yeah.
That's a different function than x plus 6.
Okay.
That's why it's called piecewise. It's
Okay.
because it's two different functions on the same curve. Well, if I plot y equals minus 3x, that goes through this point here, as a negative steep slope, negative 3, like that.
Okay.
Goes forever, both directions, and this one is y equal minus 3x, and it's a circle right there. You can never have two closed dots in the same spot on the y-axis, because if I did, it would flunk the vertical line test.
Yeah.
Notice this passes the vertical line test.
Okay.
It's to the left of the x-axis, the function is x plus 6. To the right of the x-axis, the function is minus 3x.
Okay.
And at 0, it's x plus 6.
Okay.
So at 0, it would be equal to 6. Okay? Let's look at 17. Remember, we're going to start here. So our dividing point is at minus 4. And we only have two functions. We have everything to the left of minus 4, and we have everything to the right of minus 4.
Okay.
So the best way to draw that point is to substitute minus 4 into that function. And what do you get? What's 4?
So minus...
4 times minus 4 plus 2.
Negative 14.
Okay. So I'm going to go down here and draw an open circle at minus 4 minus 14.
Okay.
Okay? That's where my function's going to start. What's the slope on it?
The slope would be 4x, so just 4.
Just 4.
Yeah.
Slope is always just the coefficient. So the rest of the line, I'm going to go up 4 over 1. There's a point on my line. And, I'm the wrong way. It only is that when I'm left. So instead of going up 4 minus 1, I'm going to go down 4 and left 1.
Okay.
See why? Because this function is not that function to the right of minus 4. It's some other function.
Okay.
So I don't need to extend this function to the right. It doesn't extend to the right of that circle. To the right of that circle, I have a completely different function, 2x minus 6.
Okay.
Okay? Well, where is 2x minus 6 at minus 4?
At minus 4.
Because this is where we're going to start this second function, is at minus 4. So plug it in and solve.
Okay, so...
Evaluate the second function at minus 4.
Okay, so it'd be 2.
No. At minus 4, you have 2 times minus 4 minus 6. What's minus minus 6?
That'd be negative 14.
Aha. Close dot over top of our other dot. And now 2x minus 6 has a slope of what?
So 2x minus 6 would have a slope of negative 14.
Hold on. What's the slope of that function right there?
2.
Okay. That's what we care about. Because to draw it, I've got to go up 2 over 1. Up 2 over 1. So now the rest of this thing looks like that.
Okay, cool.
And did they both have the same slope? No, the first one had a slope of 4. The second one had a slope of 2. So this one's actually steeper. This one's a little flatter. I should have drawn it like this. Okay. And then that's a piecewise function. Now, they ask one last question. What's the domain on this function that I just drew here? What's the domain and range? Tell me what the domain is.
All real numbers.
What's the range?
All real numbers.
Very good. Same thing with the other one, I believe, if I remember correct. Yeah. The other one looked like to the left of 0, it was x plus 6.
Yeah.
And to the right of 0, it was negative 3. Oh, hold on. Yeah, this doesn't have a range of all reals. In other words, it's x plus 6 to the left, which is this line right here, and then it's minus 3x to the right of 0. So what's the domain?
So the domain...
Domain looks strictly to the x values.
Yeah, so the domain would be negative 3. So
no.
Y is less than or equal to
Don't look at y, look at x.
So
what can x be here?
Negative 3.
This arrow means it goes on forever. So does that arrow.
Yeah.
So if I'm looking at the x-axis, here's a point, that might be minus 10 comma 3, minus 3. But way down here, that might be minus 100 comma 3. And in a positive direction, we could go out to 1 billion. In other words, x is not restricted. I can go from negative infinity to positive infinity. Make sure you understand, see why that is from looking at the curve. You're not looking at the y values, you're looking at the x values.
Okay.
X values go all the way to infinity, negative infinity on the left, and they go all the way to positive infinity on the right. If I had a big enough piece of paper and extended this curve in both directions, you would see that. That no matter where you looked on the x-axis, you would have a function. So domain is all reals. Range is the thing that's limited here. The y values are limited. What can y be?
So y could be negative, so negative 3. So it could be y is less than or equal to 0.
According to my graph, that's what it says, yeah. Y is less than or equal to 6. 0, excuse me.
You good.
Okay? Just from looking, if my graph is drawn correctly, then y is less than or equal to 0. It can be 0. And it can certainly be negative. It goes all the way to negative infinity. But it doesn't go up above the x-axis. There are no values of y that are positive in this function. So when you're figuring domain and range, if you have a graph to look at, and you do, because they say graph the function, so just look at your graph. Now, I'm not sure what it is about this that confuses people, but something does. You're not the only one that has problems looking at these things and figuring out domain and range. Let me give you just an example or two.
Okay.
What's the domain?
The domain would be all real numbers.
What's the range?
The range would be y is greater than or equal to 0.
Not 0.
Or -1.
There you go. That's
Okay.
all there is to reading this stuff.
Okay.
Okay?
Cool.
All right. I think that cover the sheet.
It did, yeah.
All right.
And then 18 was just, the problem from like last night.
Okay. All right. I will let you go.
Okay, cool.
Okay? Good luck on your quiz.
All right, awesome. All right, thank you.
All right, Dylan. Bye-bye.
Okay, bye.